Hey folks, welcome back. So this video is going to answer a email on how do I size properly the size of my motors to the size of my airframes on my electric airplanes. If you're new to my channel, welcome, but my nickname's Dag, and I'm obsessed with giant scale electric radio control aircraft. I'm also a full-scale pilot, but that's gotten too expensive, but that's kind of a relative term because my models are almost as expensive as flying full scale now. But the reason I have this channel is I try to share with you only the things I've done personally, so the success I've had, maybe you can have that type of success. I hate to put anything onto the internet where I'm just speculating, because if it doesn't work for you, you know, you've wasted your time and money. And I've been doing giant scale electric for about 12 to 15 years, and I've had some incredible success. And I've been in RC since about 1979, started out with gliders. So hopefully what I share with you, you can learn something from. And if you try to do what I'm doing, you can have the same kind of success. I also share a lot of the things I've done wrong, so you don't accidentally go down that same path. So what we're going to talk about today is what happens when I want to design one of my aircrafts from scratch. How do I know how big to build that aircraft relative to the size of electric motors I own or I may purchase? Before I get really deep into this, I want to play a little bitty video for you, because the world is full of so many subliminal messages and so many messages out there that it makes us all think that everything has to be hyper hard to do, has to be calculations and all the, calculus and all this crazy stuff that we have to do to figure out how to size like an airframe to a particular power plant. Because I've gotten all kinds of people say, what kind of math are you doing, and what kind of software are you using, and how hard is it to really do what you're doing, Dag? And, I don't want to say it's not hard, because I've been doing it so long. I've just always been persistent, and I stay with it, okay? I don't give up very easy. But here's the reality. What you're seeing in the video right now is a Hacker A60-16L on a experimental four-bladed prop. I've got my watt meter hooked up there. I got my voltmeter hooked up there. And I'm just experimenting with how many watts and load there is on this particular propeller. Here's a six-bladed propeller I invented and made myself. It's carbon fiber. And this is me spinning it up and also testing it to see what the load is on the ESC, the load on the battery is, the voltage I'm pulling down. And I create kind of a matrix to know what each of the motors I own, the size of propeller, two-blade, four-blade, two-blade, three-blade, four-blade, and my six-blade for my C-130J I was building. So by doing all of this, I end up understanding basically what size airplane that's going to fit into. Okay? So if you kind of think about it for a minute, when we fly our model airplanes, we want them to look somewhat scale. We want them to look somewhat like an airplane. And the reality of it is that the size of the propeller, for me, is one of the most important things. My MSL-2, which was the big yellow and blue plane I showed you earlier, the propeller is 32-inch with a Hacker A150 dash 10. So it's 150 kV. Gives me about 6,000 watts. And basically what happens is that airplane propeller is actually too small proportionally for that airplane. It's the only thing about the MSL-2 that drives me completely ape, is that I hate seeing airplanes, especially GBs, that have these little bitty propellers. So what I try to do is I try to figure out how to size the diameter of the propeller to the motor, and then that motor to the airframe. So if you think about, and also if you notice in this model right here, this 3D model, I have the flying surface as yellow. So when I'm thinking about building, picking a subject for a design, I always mark red as the motor, yellow as the flying surfaces, and normally green as the landing gear. and then orange is like ancillary stuff that I'm going to like drop off at like bombs. And I may even have a blue in there if I've got a sliding canopy. Okay, but when you then look at this C-47, we then say, well, how many inch wingspan should we have? Well, I happen to know for my Hacker A60-16L, a 3-bladed prop will easily go up to 21 inches and not overheat the motor, not overload my speed controller, give me about 2,800 watts, I think, on a 6 or an 8S, I can't remember. And then I basically adjust the scale of the airplane to the size of the propeller relative to the size of the motor that's turning it. Okay, and I'm going to get into this a little bit deeper here in a minute. You know, you look at a Stearman, I would do the same thing. P40, I would do the same thing. Now, if you look at this ME-109, you'll see I've got a Hacker drawn, and I have a diameter showing the diameter of the propeller. And basically what I'm doing here is I know that that Hacker A60-16L will turn that 21-inch prop perfectly. So I scaled this 109 to a 21-inch propeller, which gives me about a 95-inch wingspan. That way the prop looks scale. I know the motor is going to turn that propeller at a certain wattage. And if I built that airplane at a targeted weight, I would know what my cube wing loading is. I know what my watts per pound is. And then my airplane would be pretty much good to go. Same thing if I was doing this 190 here. Now here you can see the orange is things that would drop off it, and the blue is a canopy that would open, and the red would be the power system. But I guess one of the things that is kind of important to think about, this airplane though, I sized to my Hacker A150 that's in my MSL. And I know it turns a 32-inch two-bladed prop at 6,000 watts, and I know that it turns a 3-bladed 27-inch propeller at 6,000 watts. So if I were to build this airplane matching that propeller, it would be 95.5-inch wingspan. That's 8 feet, baby. So that would be a kick-ass 190, have an 8-foot wingspan 190, okay? So what I'm going to do now is I'm going to jump over to my Fusion 360 for a second. And what I want to talk about is when we think about designing an airframe. If you've been one of my longtime followers, you know I like to start in AutoCAD and design all the bulkheads. I do all the ribs and the flying surface, tail feathers in my CompuFoil. So once I've kind of, for me, okay, this is me personally, okay, I'm not saying this would work for you, and I'm not telling anybody else to go out there and do this. This is what works for, well, actually, I am telling you, if you do exactly what I do, this would work. So I build the entire airframe in my 3D environment, well, 2D environment, and then take it into 3D environment, and get basically it done. But I started with the premise of what motor I would put into it. Okay, I've seen times where I've built the whole thing in 3D, and then I start to scale it. Servos don't fit, things don't fit right into the airframe. But if I start with a premise of a motor I already own, because I own 6 of the Hacker A60-16Ls, 4 of them is going into my cargo plane. That leaves me 2 extra. So while I'm not in the next foreseeable future going to build any of these warbirds, because I've got to build my B-36 in the future, my Mosquito, my T-28, all of that stuff. I've got like 5 planes in line. Now, if I win the lotto tonight, then I'll hire a gaggle of friends to help me build this junk. But when I go to build one of these warbirds down the road, I am going to start with the premise that I'm going to use a motor. But you can always go bigger. So let's say I built this 109 for my Hacker A60-16L, okay? And let's say it had a 85-inch wingspan. And I then decided I wanted to go to a 150 kV motor, go up to 96-inch wingspan. Let's say I wanted to go to something like an 85 kV motor, wanted to go up to 120-inch wingspan. I could do that. But there's also another thing that I want you to keep in mind, and that's building a belt system on the motor or a gearbox system where you could turn a bigger prop on your electric motor and have a scale propeller and actually have a smaller motor. These big airplanes don't have to fly fast. But with this Hacker and this plane, it'd be ballistic. With the Hacker A150 and the 190, it would be ballistic. But let's just say we want a scale flying warbird that's really light, kind of like my MSL2, which is not a warbird, but it's really light. 188-inch wing, 61 pounds. That's pretty freaking light. Let's say I wanted to build something around 120-inch. Well, what I would do is look at what diameter propeller that needs to be. I would then look at the pitch speed of the propeller. So if you're going to build a gearbox, you're going to need to make sure your propeller turns enough pitch speed. And basically what pitch speed is that if you want the plane, and look, I'm kind of being a little bit generous with this, but if you want the airplane to go 50 miles an hour, you want your pitch speed to be about 60 miles an hour. Pitch speed is the pitch of the propeller as it goes through the air for a given RPM will produce you moving through the air at a given speed. Okay? I've never seen any results yet that shows that an airplane is clean enough that if you had a 60 mile per hour pitch speed that your plane could actually go 60. Most of my airplanes, when I do the math and it says I've got like a 65 or an 80 or a 90 pitch speed, my plane's normally doing about 10% less than that. Okay, maybe 15% less. So you don't necessarily have to have a big old low kV motor to turn a big old prop. You could belt drive it or you could gear drive it. Okay, I've built a couple of those systems, and you do lose a little bit of efficiency, but because it's an electric motor with massive balls of torque, they don't really care that much because all you're going to do is lose a little bit of flight time. If your ESC is sized right and the motor's right, that you don't overheat the motor. Okay. And that's the last thing I kind of want to talk about here. If you're thinking about sizing a motor to an aircraft, when you've got a 190, you've got what would be a radial engine up there with a lot of air coming in the front. If you got a 109, there's not a lot of air coming into that because that was a water-cooled engine. So in real life, I mean full scale. So you do need to think, how am I going to get some cold air to that motor if you're going to really be, turning the maximum watts that motor is designed for. Okay? Because one thing about warbirds that I've learned electric warbirds with my pals and tinkering around is that they're not cubs. If you had a big old massive heavy cub, here's a better example. My MSL2, when I take off 6,000 watts, get it into the air, once I'm cruising around, I'm down to about 4,000 watts. And then I'll just fly around like it's a happy airplane. If I climb, I might go back to 6,000 watts. If I do a loop, of course, I'll probably go to full power. But I'm probably only flying full power for takeoff and maybe 10% of the rest of the flight. Warbirds, for some reason, we don't have any self-control. We want to go fast with them. We want to do full throttle flybys. So we are going to be seeing a lot higher watt over the duration of the flight of the airplane. So you need to think about how to get air into that motor to make sure you're cooling it. Okay. One nice thing about the Hacker A60-16L is you could probably fry an egg on them and not hurt them. And I've had my 6 for 11 years now, and I have run the crap out of these motors. In test cells, I've had a couple of projects that I did with some friends that is kind of top secret, where I wanted to see how much load I could put on them in the air. They're to me one of the coolest electric motors ever built. Now, on the reverse of that is my A150, or is it A100? I think I got these backwards. I think it's the A100 is the 150 kV, and the A150 is the 100 kV, and I don't know why Hacker does it. I think I actually own a A100-10, not the A150, because the A150 is the 150cc equivalent. So my A100, and I misspoke earlier, it's not the A150. So my A100-16 or -10 turns my 32-inch prop. That motor gets really hot, and I've heard of people having magnets sometimes delaminate inside the bell or whatever you call it. But when you're thinking of sizing an airframe to a motor, I find the motor that is the happiest with the propeller, and then scale what the scale diameter would be it quarter scale, third scale, fifth scale, to the diameter of that propeller, and then matching that to the size of the airframe. I hope that makes sense to everybody. So essentially, when we think about anything that I'm designing right now, my Mosquito, my T-28, one reason my T-28 has taken me so long is that thing's going to need a 44-inch or 46-inch diameter propeller. That has to be on a belt drive or a gearbox system or a multiple motor system that would drive through maybe even its one-to-one gears to a shaft. But I'm going to need something like 20,000 watts to fly that T-28, because it's a massive T-28. I mean, when you got a 180-inch wingspan T-28 that's going to weigh right at 70 pounds, it's going to need a big old scale propeller to look right. I don't want a propeller that's only an inch bigger than my cow. Even my MSL2, that embarrasses me a little bit. So that's pretty much it, folks, this time. I got an email or two saying, how do I really figure out the size of your airframe to the motor that you're going to use? So believe it or not, I pick the motor first. I find out what size propeller it will turn. Now, if it's a Stearman, when you got a two-bladed prop, your airframe may be a given size. If it's a three-bladed prop, normally you're going to go down a couple of inches in diameter. If it's a four-bladed prop, you may even go down even more in diameter to see the same watts that it's going to be drawing. Okay? So I hope this makes sense, everybody. I know sometimes it makes sense up here, and I'm trying to articulate it in a way that just about anybody can understand it. Because I always get emails, can I dumb it down, or can I make it more simplistic, or can I say it more in layman's terms? And I think I'm doing that. So you always know I end my videos with begging you to get a kid flying airplanes, okay? And it's so important, folks. I did a video the other day where I answered some emails, and I did a video where I did about remote ID. And I literally got 50 different private messages, emails on my Gmail, and a couple of comments on YouTube where people are talking about the youth and what this is all going to mean for them. Bottom line, if you're a mom or dad, and I already know you're kick-ass, okay? I mean, you are just fabulous. And what you're going to do is get your kid little gliders that they throw, and they figure out how to bend the wings left and right a little bit. That's the ailerons, okay? I mean, the Wright brothers did wing warping, and some of our little balsa wood planes, we can do it. If you take a little bit of alcohol and water and put it on the balsa wood, and you bend it and hold it until it dries, it will stay in that shape. And you can teach them how to make planes turn left and right. You can teach them how to bend the elevator up and down a little bit and make it go up or down, even do loops if they throw it hard enough. You get them into rubber power. Now, this is really inexpensive, and honestly, if you can't afford these little gliders, reach out to me through my Gmail, and I'll send you some gliders. I'm not kidding, okay? And I'll put my Gmail in this video. I mean, on the descriptions below. But the thing is that I am terrified when I witness, because I travel sometimes, and I'm in places for work and play, and I see a kid on an iPhone, and they're shooting people. They're in a mall killing people, or they're running through a forest killing people. The brains are sponges between about 4 years old all the way up to 12. This is where we form people. I'd rather form people into being Neil Armstrong, Chuck Yeager, Scott Crossfield, Harrison Storms, who was an engineer for Apollo, who did the X-15. I would rather shape these kids to be something cool in aviation than being mass murderers one day. And I'm telling you, once you get a glider in a kid's hand, or a rubber-powered airplane in a kid's hand, the next step might be a little 2-channel or 3-channel model airplane. So, if you're watching this and you're a parent, I know you're kick-ass. I know you're not letting your kids kill all these people inside malls on video games. You're probably right now thinking, where do I buy these little gliders? Type in Gillo's balsa gliders or something to Amazon. I think you can buy like 100 of them for something, or 10 for something, or whatever. But seriously, if you can't afford it at all, if you have no money at all, and you live in the continental United States, send me an email through Gmail, and I'll buy some and send them to you. Even if they're for you, if you're just some lonely mom or dad who's 25 or 30 years old and you've got your kid there, even if they're like 2 months old and you want to get into model aviation, I'll send you gliders. So I'm not kidding, folks. I want to get people into aviation because it teaches physics, science. It teaches so much. The world is just kind of creepy right now. So rock on, everybody. Thanks for watching my videos. If you watch this long, it means you must like this, or you think I am completely a crackpot. So please like and subscribe. I'm trying to build my YouTube. I've said it many times, between my YouTube, Patreon, and some sponsorship, I'm trying to completely afford to do my hobby without taking it away from my daughter's college fund. Because she's going to be a doctor one day. So, which is a boatload of money. So rock on, everybody. Have a fabulous day, and get a kid flying. I used to say get a kid into the air, but somebody emailed me and says, "Do you want me to throw my kid?" I'm like, no, don't throw your kid in the air. Get a kid flying, okay? And just get your kids away from the video games, okay? Rock on, everybody. I'll see you next time. Be safe and stay cool. Bye.